In our last class, we talked about some properties of multiplication, and we ended off with a uh, comment or two about the distributive property. When I see an expression, an addition or subtraction expression within parentheses, and a number on the outside, the product of those terms can be obtained by the distributive property. In this first problem, I see a negative on the outside of the parentheses. That's just telling me the opposite of what's in the parentheses. It's also the same as if I had multiplied by -1, and by doing so, that just changes the signs within the grouping. So I'll then get a -7x squared plus 5x. Changes the signs. To the right, I'm multiplying by 6x squared. When I multiply the coefficients, I get 24. And x squared times an x squared, you add your exponents, x to the fourth. I now multiply that 6x squared. The key to distributive property is to remember to distribute to both terms. X squared times x is x to the third. On the second row, I'm multiplying by a -3, and that's going to change the signs, and I'm going to get 15x. And second time, the negative times a positive will give me a -12. Can't simplify these any further because they're not like terms. I'm going to get to that in just a moment. All right, a -3x, we're going to change the signs, and then we'll just multiply and add exponents. Change the sign, multiply, there we have it. Let's look at how we simplify expressions a little bit further. When we want to simplify an expression, we may have to use the distributive property, but we could also be using something called combining like terms. In a term that is a product of a number and a variable, that number is the coefficient. So in a term like 6x, 6 is the coefficient. Remember, a coefficient is just a number. Like terms are terms in an expression that have the same variable raised to the same power. I could have 7x plus 2x. And if they're like terms, they can be simplified or combined. That means you can add or subtract them. If I have an expression that contains numbers without variables, these are called constants, and they're also considered like terms and can be added and subtracted or combined. So again, some key terms that we want to be focused on. The word terms, for example, if I were to give you (6x plus 4) has two terms. Those two terms are 6x and 4. They cannot be combined because they're not like terms. The number 4 is a constant because it doesn't have a variable attached to it. The number 6 is a coefficient. It's the number preceding or coming before the variable. This expression cannot be combined because they're not like terms. At a first glance, this looks like an expression with three terms. However, it can be simplified. Because the first term and the last term are like terms, they can be combined. If I wanted to, I could use my commutative property and move this over. I could then use my associative property and add those first, and I get a -2x plus 3. So this expression, when simplified, has two terms. I have a constant of 3 and a coefficient of -2. It's important to know how to simplify because we'll be doing that as we're solving equations. So let's take a look at a few examples of how we can go about simplifying expressions. This first one is nicely set up because the like terms are directly next to each other, so I don't have to do any commutative or associative property here. 8x plus 3x gives me 11x. Remember, like terms stay like. I didn't change my exponents because I'm not multiplying. When I'm adding, I'm basically looking at this as saying this has 8x plus 3x. They have a common term of x, which leaves me with 8 plus 3. So 8 plus 3 is 11. That gives me 11x. Okay, so that's one way to look at it, is if I take out that common factor and I add those coefficients, that's what I get. That's what I'm doing when I do combining like terms. And then I do have some like terms because constants are like terms as well. And that tells me to subtract 11x plus 3. To the right, I have another problem. And again, if I wanted to, I could do it mentally or I could rewrite it. The first term is like the last term. And I take the sign in front, so I have 4x squared minus x squared plus 2. Well, if I take 1x squared from 4x squared, that leaves me with 3x squared plus 2, and now it's simplified. An expression is simplified when there are no like terms, no parentheses in them. This one has a little bit of both going on. I first will distribute, and I'll get 8x plus 6. I now see that I have a like term in the front as well as the last term, so I'm going to get a simplified version of 8x plus 9. This next one, I'm going to be distributing this negative, and again, I remember that I need to distribute twice. I see some like terms to combine, and 10 minus 4 is 6. One more problem to look at, and I see that I have a 9x squared minus 4x plus 5y minus 6. If I were asking you to simplify this, hopefully you realize you can't. There are no like terms. It's already in simplest form. What can I do with an expression like that? The only thing I can do is evaluate it if I give you the values of x and y. Try 2 more, and we'll do these 2 in class. Again, you have a combination of distribution and combining like terms. Now there are 2 more sections left in this chapter, but after the next section, which is the division of real numbers, we're going to have a chapter test. And I'm looking at early next week for that chapter test. We're then going to do a short lesson on probability and odds, but that won't be on the test. So let's just take a moment or two to plant the seeds for this next lesson. And you'll see that it's quite easy because the rules of division of signed numbers are the same as the multiplication. Now, in this, we're going to be talking about reciprocals. And a reciprocal is just a flipping of a number. It's called the multiplicative inverse. And the product of any number and its reciprocal is 1. That's going to be helpful to eliminate fraction coefficients, to simplify expressions. 0 is the only real number that does not have a reciprocal. There's no number when multiplied by 0 that will give you the product, a product of 1. So when we think about that, we look at that as being an exception to the rule. So here are some simple division problems. The rules are the same as multiplication. Same sign, positive quotient, unlike signs, negative. So you could quickly go down the line and see opposite signs, negative quotient, same sign, positive. We can never divide by 0. This is undefined. And the last one is 0. Many times you're going to see division problems written in this fraction form. One last type of problem here that I want to show you is a division of a problem that looks like a complex number. We can simply take this, and it's read 3/5 divided by 2/3. Hopefully you remember that when you divide, you're going to multiply by the reciprocal. 3/5 times 3/2, the reciprocal. If we can cross cancel, which means simplify before we multiply, we will. If not, we'll multiply our numerators and our denominators. Excuse me. There's a little more to this besides what I'm just introducing here. We're going to look at that division rule as to divide a number by any non-zero number. You multiply by the reciprocal, because remember, we can never divide by 0. Some people call it the keep change change, the keep switch change, keep switch flip. There are so many different ways that people remember, but we just remember that we're going to multiply by the reciprocal. 3/4 times the reciprocal. Again, if we can simplify before we multiply, we do. And done. 16 times the reciprocal would be 1/-2 and -8. 4 times the reciprocal, be careful on this one, 1/4. So these are just a couple samplings. We'll do more on Monday on our next class, and we'll be preparing for a test early next week. Thanks for your time.